In today's lecture, we are discussing what is refrigerator and what is difference between a heat pump and a refrigerator. As is evident from the principle of Carnot cycle, if all the operations in the Carnot cycle are performed in the reverse direction, there will be an absorption of heat Q2 from the sink. That is, I repeat, if there is a high temperature reservoir at temperature T1, low temperature reservoir at temperature T2, heat pump or refrigerator, there will be if Carnot cycle is operating in a reverse direction, what would happen? There will be an absorption of heat Q2 from the sink or the cold body at temperature T2 and transfer an amount heat Q1 to a high temperature reservoir T1. Now, from the second law of thermodynamics, no transfer of heat can take place from a cold body to a hot body without some internal agency that supplies the requisite amount of work. So, some mechanical energy has to be supplied to the engine to make it in the reverse direction. Thus, we have Q1 is equal to Q2 plus W. The Carnot cycle working in the opposite direction can perform the following function. It can further cool the cold body and it further heat the hot body. When a reverse heat engine is used to further cool the colder system, arrangement is called refrigerator. And when the reversed heat engine is used to further heat the hotter system, it is known as heat pump. Now, in an ordinary household refrigerator, working substance is a liquid that circulates within the system. It takes heat Q2 from the sink or the cold body at temperature T2, transfer Q1 at higher temperature T1. Q1 is equal to Q2 plus QW. The work is supplied by the compressor that was electrical energy that uses electrical energy. The working substance is a fluid that readily undergoes a liquid to a gas phase change at the operating temperature. The most common refrigerator are Freon 12, CCl2F2 and ammonia. The quantity Q1 which is expelled into the room is the reason why the room gets warmer when we switch on the fridge. The performance of the refrigerator is given by a constant called coefficient of performance, that is beta. Beta is defined as heat taken from the storage divided by the work input, that is refrigerated effect by net work done on the engine. Since W is equal to Q1 minus Q2, so the performance of the refrigerator is given by Q2 by W. Q2 Q1 minus Q2, it becomes T2 T1 minus T2. This is what I was talking, that in ordinary household refrigerator, working substance is a liquid that circulates within the system. Work is supplied by the compressor that uses electrical energy, and the most common refrigerant are Freon 12 and ammonia. Further, a point to be noted, as T1 is greater than T2, so beta is greater than 1, unlike the engine where beta can be greater than 1. Efficiency is always less than 1, but beta can be greater than 1. Then there may be certain numericals which could be asked, that what is the relation between the efficiency of heat engine and the coefficient of performance of refrigerant. Since efficiency is given by T1 minus T2 by T1, so efficiency becomes 1 upon 1 plus beta. Again, if a reversible engine takes in heat from a reservoir at 527 degrees Celsius and gives out heat at sink at 127 degrees Celsius, how many calories per second must it take from the reservoir in order to produce the useful work at the rate of 750 watt? Efficiency given है, formula T1 T2 in Kelvin. Since efficiency is T1 minus T2 by T1, 800 minus 400 by 800 becomes 1 by 2. Work done is 750 watts, 750 joules per second. Efficiency is work done upon heat, W by Q1. Half is 750 by Q1. Q1 comes out to be 150 joule per second. And since if it is needed to be converted into calories, 1 calorie is equal to 4.2 joules. So divided by joule, it becomes 357.17 calorie per second. Based on the discussion of heat engine and the refrigerator, we have the second law of thermodynamics, or rather two statements of second law of thermodynamics. First law of thermodynamics states that energy of the universe remains constant, though energy can be exchanged between system and surrounding, it can't be created or destroyed. While first law of thermodynamics gives the information about the quantity of the energy transfer, it fails to provide any insight about the direction of energy transfer and the quality of the energy. This is the limitation of first law of thermodynamics, that it cannot indicate whether a metallic bar of uniform temperature can spontaneously become warmer at one end and cooler at the other. It does not give us a direction of energy transfer. Second law of thermodynamics states that any spontaneously occurring process will always lead to an increase in entropy of the universe. In simple words, this law explains that an isolated system's entropy will never decrease over time. It is also known as law of increased entropy. We have two statements to define the second law of thermodynamics. One is based on the Carnot cycle, another is based on the refrigerator. Kelvin-Planck statement. An analysis of the operation of heat engine led Kelvin and Planck to arrive at the following conclusion, that it is impossible to construct a heat engine that will operate in a cycle and which will receive a given amount of heat from a high temperature reservoir and does an equal amount of work. The only alternative is that some of the heat must be transferred from the working fluid to a low temperature reservoir. Therefore, work can be done by the transfer of heat only if there are two temperatures involved. सिंपल भाषा में ऐसा नहीं हो सकता कि हम सारी की सारी हीट को वर्क में कन्वर्ट कर दें, कुछ हीट तो हमें लो टेम्परेचर रिजर्वेयर को देनी ही पड़ेगी. Second statement, that is Clausius statement. An analysis of the operation of refrigerator or the heat pump led Clausius to conclude as follows. It is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from the cold body to a hot body. In effect, it is impossible to construct a refrigerator that operates without an input of work. The first law of thermodynamics is concerned with the conservation of energy. As long as energy is conserved in a process, first law is satisfied. Second law emphasizes the fact that process proceeds in a certain direction but not in opposite direction. For instance, a hot cup or a coffee cools by a virtue of heat transfer to the surrounding, but heat will not flow from a cooler surrounding to a hot cup of coffee. Thus, real process proceeds only in one direction. It is important to take note of the fact that cycle will occur only if both the first and second law of thermodynamics are satisfied. Questions that asked in the board exams are: state and explain the second law of thermodynamics, give the limitation of first law of thermodynamics, write Kelvin and Planck and Clausius statement, and if room of refrigerator remains open, why a room cannot be cooled, explain your answer, or write a formula for the performance of refrigerator. That is all in second law of thermodynamics. Thank you.